So now we're trying to prove that the expression on the left hand side is going to give you the value on the right hand side. So what I see here is there's not a lot of derived trig identities, but I can see sine x here and sine x here. So when I see that, that leads me to think about factoring. So what I'm going to now do is I'm going to factor out sine x from this expression, and I have sine x multiplied, and then you open up your parentheses, so it's going to be cosine squared x minus 1. This is equal to, so if I see cosine squared x and 1, what I'm going to really focus on is the expression or the equation sine squared x plus cosine squared x equal to 1. So what I'm saying here is I see an instance where we have cosine squared x and 1. So that means I'm going to subtract cosine squared x from both sides here, minus cosine squared x minus cosine squared x. So now I have sine squared x equal to 1 minus cosine squared x. But what do we see within the parentheses? We see cosine squared x minus 1. So what that simply tells you to do, and if you can look right here, you see that the sign here is negative. So what we can actually do is multiply this whole expression by -1. Let's see what that does. So it's going to give us negative sine squared x. And just generally in math, when you see this type of a situation where your signs are not specifically on the expression or the variables you want, you can always multiply by -1 to switch them and see if that gets you to what you're looking for. So this is negative sine squared x equal to -1 plus cosine squared x. So what does that mean? Negative sine squared x equal to cosine squared x minus 1. So now this sine x cosine squared x minus 1 is going to be the same as sine x multiplied by negative sine squared x, which is going to give you negative sine cube x, and that's what you're trying to prove.